All right, go to, I think it's the second page, you're gonna have the GeoGebra activity. There's a little GeoGebra activity we're gonna do that's going to highlight 4 theorems you're gonna get in section 2. And basically this is a little discovery project. As you go through this, you're gonna kind of learn what the 4 theorems are. Here's what I want you to do today. A few things. First of all, we're going to put a definition up here. This is about parallelograms in chapter or section 2. Carlos will be with you yet. So let's define a parallelogram first. So we're just going to squeeze this in at the top of your paper. And we have a symbol we use for parallelogram. It's kind of like a rectangle that's been tilted to the right. And you'll see that symbol occasionally. When you see that symbol, that means parallelogram. And I want to give you the book's definition here of a parallelogram. A parallelogram is first of all going to be a quadrilateral. And we know from yesterday, quadrilateral is going to have 4 sides to it. And then both of its pairs of opposite sides will be parallel to each other. Hopefully you got enough room to squeeze that in at the top. Also, let's draw a picture of what a parallelogram is going to look like. It's going to look a lot like the symbol. It can either tilt to the right or it can tilt to the left. I'm going to draw with the tilt to the right here. And by our definition, you're going to have a quadrilateral, so there's your 4 sides. Both pairs of opposite sides are going to be parallel to each other. So the left and the right hand sides are parallel. To show that, I'm going to put a little flag on each side. And then the top and the bottom are also going to be parallel. So I'm going to put 2 flags on that. So that's the definition of a parallelogram. That's kind of what you want to think about as you're working your way through this GeoGebra activity. So what I'm going to do is give you about a half hour to work on this. And there's a few things I want to point out. Here is the website that you're going to go to. And when you get to that website, you have to go down here where it says start. You're going to start where it says answer the questions below. So you have to scroll down a little bit before you get to the part where you have to start. If you start all the way up to the top, it's going to mess things up. So make sure you scroll down below where it says answer the questions below. And then what I want you to do is work your way through this all the way through number 5 at the back of the sheet. Basically, work your way through the fill in the blank part. Go ahead and fill in those blanks. This stuff down here at the bottom, these examples we're going to do together in class. So just wait on those. You don't have to do those together. All right. So I'm going to give you about a half hour. That's going to take us till 1:55. Make sure that's going to give us enough time. Yeah, that should be good. All right. Those of you at home, don't leave. Go ahead and work on that for the next half hour. I'm going to turn off my video and mute myself. When I come back, we'll work on, we'll take you through those examples we were going to do. All right, let's bring everybody back here. And Andrew, can you hit that backlight again, please? Thank you. Okay, I want you to go to the back of to the second page, and right in the middle at number 5, we're going to kind of summarize what we just learned. And going around and looking at it, some of you had the right idea, your wording is just a little bit off. So if you wrote the wrong wording, we're just going to have to change it to what the theorem will say in section 2. So as you were going through this with the parallelograms, certain things are going to happen on every single parallelogram. The first one is opposite angles. And what I'm going to do is I'm going to number this, number 1 right here, so I can draw a picture of what's going to happen. So on number 1, I'm going to draw a parallelogram. And then opposite angles are angles that are diagonally across from each other. So like these two angles here would be opposite angles, and these two angles here would be opposite angles. And what you hopefully found out in there, your opposite angles will always be congruent. So if you didn't have congruent there, cross off what you did and write in congruent. And then for a picture of what's happening with number 1, your opposite angles are congruent. That's going to make these two angles congruent. And it's going to make these two angles congruent. And that will happen on every parallelogram. Opposite angles will always be congruent. All right, the second one I'm going to call number 2. So we can draw a picture of that also. And on this one it says adjacent angles. Our book calls it consecutive angles. That's what it called it back in chapter 2, I believe, or 3, when we learned about consecutive angles. So you may want to change that adjacent to consecutive. It's not terribly important, as long as you remember what we're talking about here. Consecutive angles are going to be angles that are right next to each other. So on my parallelogram here, I'd be talking about these two angles. I'm going to call them X and Y. Those two angles are next to each other. And then if you go back to what we just learned, your opposite angles are always congruent. So if this angle is X, this one down here would also be X. And if this angle is Y, its opposite angle would be Y. So now on that picture, I can pick any X and any Y and add them together. If I pick this X and this Y and add them together, or I can pick these two, I can pick these two, I can pick the top two, whichever ones I decide. If I add X and Y together, we will always get 180. And this goes back, I think it was chapter 3, when we did parallel lines. We said if lines are parallel, then your consecutive interior angles are going to be added up to 180. And if you remember, on a parallelogram, your opposite sides are always parallel to each other. So X and Y will add up to 180. So we have a word for that. When they add up to 180 in geometry, we call that supplementary. So if your wording wasn't quite correct, cross it off and put in supplementary. Your consecutive angles will always be supplementary on any parallelogram. All right, third one, I'll draw a picture for number 3 down here. Number 3 could be answered 2 different ways. I'm just going to ask about opposite sides on parallelograms here. Now, when we define a parallelogram, we said a parallelogram's opposite sides will always be parallel. So these two, left and right, are going to be parallel. Top and bottom are going to be parallel. But another thing you found out going through here is that the top and the bottom will also be congruent to each other. Same thing with the left and the right. So we can now say that opposite sides will also be congruent. So by the definition, they're parallel to each other. By the theorem, they're congruent to each other. Both of those happen on every parallelogram. And then our last one, I'm going to call number 4. Picture for 4, we need diagonals on it. Diagonals are going to cut across your figure. And as I was going around looking at your answers, a lot of you are on the right track, you just weren't able to word it correctly. When you have a parallelogram, these diagonals are going to split each other in half. So this diagonal is going to get split into 2 congruent parts. And this diagonal is going to get split into two congruent parts. Now, the wording we're looking for that goes back to, I think, chapter 2. When things cut each other in half. Anybody remember what you call that when in geometry when you cut them in half? Yep.
Bisect.
They're going to bisect each other. There we go. Diagonals bisect each other. So on every parallelogram, your diagonals will cut each other in half. Both diagonals will get split into two congruent parts. Now, what you probably want to do is somehow highlight this little box right here, because as you're doing the homework for this and getting ready for your next test, this is section 2 right here. There's 4 theorems in section 2. It's these 4 theorems right here. And then what we're going to do tonight on the homework is just, they're going to give you a picture of it. We're going to use these theorems to come up with our answers. So they're going to ask us to find x and y in our pictures. So go down to the bottom of that page. We'll start with number 1. Number 1, it's a parallelogram, so we know all of the opposite sides are going to be congruent to each other. And on this one, they made all 4 sides the same. But you know that the opposite sides, those two are always going to be congruent. These 2 opposite sides are always going to be congruent. In this case, all 4 of them have to be congruent to each other. That usually doesn't happen, but sometimes it does. Now we're going to use that to come up with x and y. So I'm going to start with these 2. 6x and 12, they're opposite sides on a parallelogram, so they're congruent to each other. So 6x would equal 12. And divide by 6, x is going to be 2. And then we'll do the same thing with the other one. We've got 3y here. This side is not marked, but we know that all of these sides are the same. Since this side is 12, this side also has to be 12. So to find y, we'll set 3y and 12 equal to each other. And if you divide by 3 on that one, y is going to equal 4. And I should point it out as we do this. This one is using our first, no, not first. It's using the third theorem. Opposite sides are congruent to each other. All right, let's go to number 2. Number 2, we got 3y here, 6x here, 12x here. I'm going to start with the 2 x's. The 6x and the 12 are consecutive interior angles. They're right next to each other. If you go back to your theorem, consecutive interior angles on any parallelogram will be supplementary, which means they add up to 180. So that's what we're going to do with x. 6x and 12x will add up to 180. And if you collect your like terms, 6x and 12x add up to 18x. And then divide both sides by 18, x would be 10. Now we also need to get y, which is up here on this angle. And there's 2 different ways you could do it. We could add these 2 together to equal 180, or we can use these 2 opposite angles. If you go back to your theorem, opposite angles are congruent to each other. And that's the route I'm going to go. So what I'm going to do is take this 10 for x and put it in. 12 times 10 is 120. And then like we just talked about, opposite angles on a parallelogram will be congruent to each other. So the 3y will equal 120. And if we divide both sides by 3, we're going to get 40 for y. All right. Any questions on the first 2 before I move it up? Those of you at home, you're going to have to yell loud if you have questions. Okay. We're going on to 3 and 4. All right. Number 3, there's more than one way to do this. I'm going to show you the way I would do it. I'm not going to show you both because sometimes it gets confusing if we do that. So I'm just going to show you one way to do this. We have a parallelogram, and we know it's a parallelogram because it told us that in our directions here. Directions says it's a parallelogram. So the parallelogram is split up into 2 triangles, and then I'm going to use this one diagonal they drew in here. Since it's a parallelogram, your top and bottom are parallel to each other. Same thing with the left and the right. Those are also parallel to each other. We don't really need that on this one. And now what I'm going to do is take this diagonal and look at the alternate interior angles. If your lines are parallel, alternate interior angles are congruent. So if this one's 55, this one down here is 55. I'm going to do the same thing with the 60. Actually, I do these two sides are parallel. That makes this 60 and this angle alternate interior angles. Since your lines are parallel, alternate interior angles are congruent. So this is going to be 60. And now I'm going to do what I think is the easy way. We have two different triangles here. If you add up all three angles in a triangle, you get 180. So I'm going to do it that way. 5x plus 55 plus 60 will add up to 180. All three angles in a triangle add up to 180. And then we'll simplify it from here. We've got a 5x. 55 and 60 add up to 115. And if we subtract the 115 from 180, that's going to be 65. And divided by 5, 65 divided by 5 is 13. That takes care of the x for us. Now we also need to do the y, and I didn't leave myself a whole lot of room for the y. So let's see if we can squeeze it in on the left here. Same thing on the left. These three angles in this triangle will add up to 180. So I've got the 2y, the 55, and the 60 we've already added together. They equal 115. So let's just simplify this and say 2y plus 115 equals the 180. So once again, this is coming from all three angles in your triangle, add up to 180. We already subtracted 115 from 180 and got 65. So 2y equals 65. And if you divide 65 by 2, we're going to get a decimal. That's going to be 32 and a half. All right, let's go to 4. Number 4 is going to be a mix of our two of the theorems that we have. I've got a 2a and a 34. Those are opposite sides. Go back to your theorems. Opposite sides on a parallelogram are always congruent to each other. And then we also have opposite angles. 8b and 112 are opposite angles. If you come down to your theorems, opposite angles are also congruent to each other. So it doesn't matter which one you start with. I'm going to go with the 2a and the 34. Those two will be congruent since they're opposite sides. If you divide 34 by 2, we get 17. Then we'll do the opposite angles. 8b and 112 are opposite angles, so they'll be congruent. If you divide 112 by 8, we get 14. Any questions with those two before I move it up? All right, two more together, and then we're going to turn you loose. 5 and 6 are both very similar to each other. On 5, you've got two diagonals drawn in. You go back to your theorems. Diagonals bisect each other. So I'm going to draw on my picture what that means. Each diagonal is going to get split in half. These two parts will be the same, and these two parts will be the same. And then once you mark those parts, you can put your equations together. 3x and 12 will be equal. Divide both sides by 3, x is going to be 4. And then your other equation, the 4y and the 8, will be congruent. Divide by 4 on that one gives you 2y. And then number 6, same exact theorem. Diagonals bisect each other. So on my picture, I can split this diagonal in half. And I can split this diagonal in half. And then from there, you can make your two equations. I'm going to start with the y's. This time doesn't matter which one you start with. 18 and 4y will be equal. If we divide by 4, we're going to get a decimal this time. 4 goes into 18 4.5 times. And then your other equation is going to be the 6x and the 24. Divide by 6 there, x is going to be 4. 5 and 6 are pretty common problems that you'll see when you get to your next test or quiz. That's the type of thing you'll see a lot of. Any questions with the last two? Okay, now hang on to that. You're going to turn this in when you turn in your other homework assignment. So if you turn your page in your packet, the next page should be worksheet 6.2. Looks like this. It's got two sides to it. Front side, back side looks like this. The rest of the time you have to work on that. When you finish it, bring those two back. We'll put it in the grade book today. Those of you that are at home watching along, just do that assignment, and then when you come next time to class, we'll turn those in class next time. All right, that's really all I've got for you guys at home. Any questions for me before you leave? Okay. Then you guys can go work on your own, or you can stay on the Zoom if you want. Either way is fine. If you have questions, you can stick around, or you can go work on your own. We'll see you later. Shocking. Everybody left.